Hi, and welcome to the Master Plumbers excess flow valve sizing information session or video. Thanks for making the time to watch this. I'm Aaron, and let's get into it. So there's going to be a lot of information in this video. Some of the things we're going to be looking at is why we've got to install them, a normal gas sizing installation, the excess flow valve selection, the maximum flow rate for your piping system, the shut-off flow requirements for the excess flow valve themselves, the installation locations, a couple of installation options, and some important information. So the why. In the 5601.1 2022 update, the gas standard, they've now put in the provision, which is clause 5.2.11. This is the provision of fire emergency isolation in multi-layer piping systems. Now, it's no secret that multi-layer piping doesn't withstand the high temperatures, and particularly the high temperature that we'll see in a house fire. So ultimately it was introduced in order to preserve life, and that's by reducing fuel to a fire and ultimately slowing the spread. On the next slide, we're going to be looking at our gas installation. Now, this installation has a supply pressure of 2.75 kPa. It's natural gas, has a 30-metre main run. It has a instantaneous water heater, a ducted heater, and a cooktop. So when sizing our multi-layer pipe installations, it's important to understand that the manufacturer's sizing guides differ slightly in their installation practices, and particularly their megajoule capacities. So it'll change slightly between the brands. Some of these brands require fitting corrections, some of them don't require fitting corrections. So it's important that you understand the piping system that you're actually working with. So for this particular installation, you can see what we've come up with for this sizing. Section A to B is 32 mil, B to C is 25 mil, C to E is 25 mil, B to F 20 mil, and C to G 60 mil. The total megajoule loading that we have on this pipe is 381. So this is probably the first new step when sizing a multi-layer gas installation, and that's the excess flow valve selection. So when you're selecting an excess flow valve, you need to ensure that the nominal flow of the valve is greater than the flow or the required gas loading for the pipe or piping section. So an example here, our total gas loading is 381 megajoules. So we're going to be looking at the GS10 valve or GS10K, multiple appliances, has an allowance of 392 megajoules. Another important thing to note is in the excess flow valve selection that there's two columns that you'll be using, which is your multiple appliances and single appliances. So what you'll see there is that when the valve is servicing a single appliance, that there's actually a reduction in the megajoule capacity. And that's because the amount of gas that gets used at once when that appliance will trigger, if you haven't sized it correctly, it can actually cause the valve to falsely isolate. So let's have a look at sizing our excess flow valves or selecting our valves. For pipe section A to B here, as we've already said, we have that 381 megajoules and a pipe size of 32 mil. So taking our 381 megajoules, we're going to go down the multiple appliances column because we know the pipe section A to B has multiple appliances, and we're going to find that 392 megajoules, which is greater than our 381. We're then going to follow that 392 megajoule row over. We're going to find that that equates to a GS10K excess flow valve, and we'll put that up there in the excess flow valve column for pipe section A to B. So we're going to look at sizing the next section here. That's section B to C. It has a 259 megajoule gas loading. We know that it's got multiple appliances on that. So we're going to head down the multiple appliances column. We're going to go to the first greater number than our requirement there, which is 392. We're going to follow that row across and find that it's specifying a GS10K again, and we're going to put that up in the sizing chart. So moving on here for pipe sections C to E, B to F and C to G, our sizing method is going to change slightly. Because they're all single appliances, we need to ensure that we're working out of the single appliance or individual appliance column, depending on what brand of excess flow valve you're going to be using. So let's look at pipe section C to E. We know that we require 199 megajoules of gas flow on that. It's a single appliance, so we'll go down the single appliance column. The first greater number there is going to be 313. We'll follow that across to our valve type and find that we've got a GS10K again, and we'll put the GS10K up in the sizing chart. So it's a good one there to show that just going to a single appliance can significantly reduce the gas capacity of that one valve. By now you've guessed it, it's a bit more of the same. Pipe section B to F, 122 megajoules. We'll follow that down in the single appliance column. First greater number is 187. We'll follow that over to the valve type. That's a GS6K, and we'll put that up in our sizing chart. So last but not least, we've got pipe section C to G. Now, we require 60 megajoules of gas load on that one. Following the single appliance column down, we find the greater number there of 79. We'll go across to the valve type, find that's a 2.5, and we'll put that 2.5 up in the excess flow valve column of our sizing table. The next step would be to understand the maximum flow rates for each individual pipe size that's used in the system and put that into a table. This is important because if a fire was to burn through the piping system anywhere, you need to ensure that there's enough flow exiting that particular pipe size that it will trigger the excess flow valve and it'll isolate the gas supply in that section. On here we know we're working with a 30 metre index length. We know that the first pipe section is 32 mil, so we'll locate the 30 metre run, the 32 mil pipe size, and meet in the middle there. And we'll notice that that 32 mil pipe will have a maximum flow of 592 megajoules. And then all we're looking at doing is entering that 592 megajoules into our sizing chart. So in order to save a bit of time, I have taken the liberty of filling out the rest of this chart with the maximum flow rates. So as we can see here, the 25 mil pipe size gets a max flow of 294 megajoules. The 20 mil gets 151, and the 16 mil gets a max flow of 70 megajoules. Now this information is going to come into play shortly. The next piece of fun is understanding the shut-off flow rates. So the shut-off flow rate or closing flow rate is the point at which the valve will fully isolate and shutting off the gas supply. So approximately it's about 1.45 times the nominal flow rate, but this varies on manufacturers, the size of the valve, valve orientation can come into play. So it's important that you get this information specifically from the brand's sizing and installation guide that you're using. One important piece of information is that some of the sizing charts that come with these valves are going to express information in cubic meters an hour and not megajoules an hour. It's a simple formula in order to convert back. Natural gas has a value of 38 megajoules to a cubic meter, so it would be as simple as the cubic meter times 38 would give you the megajoule value. So in this instance, a 2.5 cubic meter valve, or a GS 2.5K, times 38 equals 95 megajoules. So for the ease of this, I've gone ahead and put the megajoules an hour on the closing flow rates. Here we're just going to be tabulating the shutoff flow. So being that pipe section A to B, B to C and C to E all have a 10 cubic meter valve in there. If we look over at the 10 cubic meter valve on that right hand sizing table, the GS10K has a closing flow rate of 15 cubic meters, which works out to about 570 megajoules. So we'll put that one in there for now. And continuing on in the table, pipe section B to F has a GS4K, or a 4 cubic meter valve. Now that has a closing flow rate of 6 cubic meters, which is going to give us approximately 228 megajoules an hour. And pipe section C to G has a GS 2.5K, or a 2.5 cubic meter valve that has a closing flow rate of 3.8 cubic meters, or approximately 145 megajoules an hour. And let's welcome back the max flow rate. So in this part, we're going to be looking at the maximum flow rate and the closing flow rate of the sections of pipe work. So in this one, we'll go pipe section A to B. We know we've got a 32mm pipe there. That 32mm pipe on the 30 metre index run, or index length, can pass 592 megajoules of volume. It's protected by the GS10K, or 10 cubic metre an hour valve, and that valve has a closing flow rate of 570 megajoules an hour. Now, because the maximum flow through the pipe is more than the closing flow rate requirement, we're going to be fine. When we have a look at pipe section B to C and 25mm, the maximum flow rate through that pipe is 294 megajoules. It's still protected by the GS10K, which still requires the 570 megajoules an hour of flow. So we know that if you cut that 25mm line in half, it's never going to have enough flow or volume passing through it to isolate and close the GS10K valve. So are they going to work? We know that pipe section A to B meets the flow requirement, and we know that pipe section B to C doesn't. Pipe section C to E is again a 25mm line with a max flow of 294. It's still a 10 cubic metre valve, so it's going to require the 570 megajoules an hour as well. So we know that that's not going to work. Pipe section B to F is a 20mm line that had a maximum flow of 151, and that had a 4 cubic metre valve on it, and we know that that needed 228 megajoules in order to close, so that's not going to work. Pipe section C to G, 16mm, had a max flow of 70 megajoules. It's got a 2.5 cubic metre valve on it, and that required 145 megajoules an hour to isolate. So we know that that's not going to work. So what's the answer? Upsize. We know that we couldn't meet the flow requirements for those valves on 4 of those piping sections. Now, we can't reduce the valve size because those valves have been sized according to the requirements for the appliances. So we've gone pipe section B to C and C to E that were previously 25 mil are now 32, and we know that that has a max flow of 592 megajoules an hour, which is going to close the 10 cubic metre an hour valve, which requires 570. B to F, previously 20, is now a 25 mil line. That now has a max flow of 294 meg, exceeding the 228 that's required for the 4 cubic metre valve. And pipe section C to G, previously 16, is now a 20 mil line that has a new maximum flow rate of 151, and the 2.5 that was on that required 145. So we now know that the valves are going to isolate because the gas lines themselves physically have enough capacity that if they were burnt through, there will be enough volume for those valves to trigger. All said and done, your sizing table is going to look something like this. It's a little bit more complicated than probably what we're used to seeing, but that's going to give you your piping sections, your current sizing, and the excess flow valves that are required for each of those areas. So we'll move on over to the location of these valves. Excess flow valve location. So due to the fact that we sized that installation at minimum, or as minimum as we could in order to isolate the excess flow valves, this is going to be a multiple valve installation. So if we look here, we know that pipe section A to B, B to C, and C to E are all a 32 mil run, and they're all protected by a GS10K. So what we would do there is put the GS10K up here at the gas meter, and that'll protect that whole main run. Where we come into the next one would be B to F. Because we reduced down in size there to 25 mil, and we've sized that for the 4 cubic metre valve, as soon as we tee off on the branch there, we'd have to go down to that 4 cubic metre an hour valve. And then we move on to C to G, and we're down to the 20 mil line, and we've got that little baby 2.5 going in there to protect that line at the branch as well. So another option we've got here is to not run minimum sizing. We already know that A to B, B to C, and C to E were 32 mil. So we could run B to F and C to G in 32 mil as well. That means we could just use the one GS10K up here at the meter. All that you would then have to do is, when you reduced your piping size to go to the appliance or connect to the appliance, that you went straight back to copper and didn't reduce from that 32 mil in a multi-layer. So some of the other options that you've got, we've already spoken about upsizing the whole line. You could install the branches in copper. As soon as you come off that 32 mil multi-layer, if you're in copper, you don't need to protect it. So the one valve at the meter will suffice. You could do the whole installation in copper. Now, we've been getting some feedback, obviously, and we're not oblivious to the fact that copper is dearer than multi-layer, but each individual company or plumber needs to do the cost analysis for this, because by the time you buy the valves and the adapter fittings and install them, it may work out better off for you. And then there's a couple of other methods of protection, which is your automatic shut-off valves that can be linked in with the smoke alarms, or you can use an UPSO, the under pressure shut-off. So some important information here. The sizing charts vary manufacturer to manufacturer. That's across the multi-layer pipe and the excess flow valves themselves. So ensure that you are using the method that they stipulate in their installation guides, and also the figures that they use in their sizing tables. The excess flow valves have an installation orientation. Now, that could be vertically up, vertically down, or horizontally. That can change across the valves themselves. Each valve can be ordered in a specific way. Some can only be installed one way when they get to a certain size. So make sure you're across that with the valves that you're putting in. Make sure the valve that you're using covers the installation pressure range. We know that the upper limit is not too much of a concern, but we're seeing some of these lower limits not quite where we would like them to be for a low pressure installation. So make sure the valve that you select is going to cover the installation pressure range that you need. And understand the limitations on the fittings and connections. That in the standards it stipulates that a straight fitting needs to be in an accessible and ventilated location. So these aren't going to be able to be put in walls, and they do require ventilation. Another important piece of information here is that there's pressure loss across the individual excess flow valves. Now, this varies from manufacturer and the size of the valve, but the information can be found in their spec sheet. Majority of the valves saw less than 50 pascals, but some saw losses of over 300. So it can greatly affect your sizing and if you're installing multiple valves. So if you're in doubt at all, upsize your gas line if you're close to the border. It's better to be safe than sorry. So last but not least here on the important information, currently the standard requires excess flow valves to be readily accessible. So readily accessible is defined as access can be gained without hazard, undue difficulty, or the use of a tool. Now, they would consider a ladder a tool, so that's going to play a really big part in where these valves get put. We're hoping that in the near future we're going to see that that clause gets changed on the excess flow valves to make them accessible, which is going to make it a bit easier. But for now, we have to work to the readily accessible. And that brings us to the end of the video. I'm sure that there's going to be some questions out there. So the only thing I can say is reach out to your authority, whoever that may be. If you are a Master Plumbers member in any state, you can contact your local association and they'll be able to help you out with that. And as more information with this stuff comes available, we'll continue to make these videos available for everyone. So thanks for your time and have a great one.